For our last talk of the day, I want to bring on our final speaker, Ayush, to talk about what's happening in the world of DePIN, and especially kind of how do we go design more DePIN protocols without the physical part in there. So please give Ayush a big round of applause from Huddle.
Hey everyone, great to meet you. I'll just check the slides. Okay, great. Awesome. I'm Ayush. I'm one of the co-founder and CEO of Huddle01. Huddle is building the world's first decentralized physical infrastructure network for real-time communication. Now, what's real-time communication? RTC is anything what we do right now. Any kind of Google Meet calls which we do, any kind of Zoom calls which we do, Microsoft Teams calls which we do. When we chat with a GPT or with any LLM via audio or video, via voice or via video commands, that's where you use RTC. And that's what we have been building for the last 4 years now. Right now, I just basically want to talk about DePIN in general and how in DePIN, real-time communication plays a very, very crucial role. And that's where I just basically want to categorize on where in DePIN we are right now. And basically, you'll be seeing a lot of essentially different kind of blockchains there, different kind of compute providers there, CDNs, storage, and a lot of other things. Huddle01 comes under the category of RTC, which stands for real-time communication. This is something which we pioneered 4 years back, and now, fortunately, after a couple of years, we have been seeing that now in the bandwidth category, RTC has its own subcategory, which in itself is a win. There are a couple of other players in the space who have been doing some fantastic work, including Deutsche Telekom and others, which basically is trying to make sure that the way RTC has been built so far is built with a high operational cost. Right now, if I just talk about the numbers, we pay, if you're using a Zoom call, you're paying essentially $20 per month per license. And the reason why you're paying such a huge cost is because because Zoom has to pay a huge amount of money to AWS in terms of egress cost. Egress is nothing but the amount of data which you put onto Zoom or Microsoft Teams calls while doing a call. Just give an example, if we all are doing a call, we are a set of 50 people here. And if we are doing a call here, right now, for just 1 hour, we'll be uploading as much as 5 GB of data onto AWS. And this is just one room. Imagine the number of rooms which exist on a daily basis, and imagine the amount of essentially money which Zoom is paying to AWS in general. Now, just giving you in terms of unit economics, AWS pays to an internet service provider $1, but it charges Zoom $80. So it's an 80x multiplier just on the part of routing the audio and video calls. And that's where the biggest barrier of cost comes into picture. Second is the geographical latencies. The latency right now, if you're doing, that's the reason why we started Huddle01 back in the day, where what we saw was that in the time of COVID, when anyone was basically doing a call, an audio and video call, and they were in a part of the country where there was no data center, they had a huge kind of latency issues because all their audio and video calls, if you're doing a call in Singapore, was routing through a central server which is based in North Virginia. Imagine all your audio video packets routing from all the way from Singapore onto essentially a place which is situated back in North Virginia, the amount of distance it travels. The more distance it travels, the more there is jitter. The more there is jitter, the more there is buffer. And that leads to a kind of bad kind of quality of calls. And that's the reason why if you see that we have not innovated a lot in terms of communication, from the Skype days to the Zoom days itself, the scalability has increased, but in terms of how communication could become much more immersive, that hasn't happened yet. The third is the privacy aspect, and the fourth is the value extraction aspect of things. And RTC is a big market. I just wanted to basically touch upon this for a while because communication is everywhere. We need communication in all the things which we do right now. And these are the kind of categories which is emerging and keep on basically going on. It's something which is not very intuitive, but if you see in anything we do, communication plays such an important role here. I just wanted to touch upon this right now, but this is where I wanted to talk about my main topic of the day, which is in DePIN, we talk about DePIN is decentralized physical infrastructure network, which has a physical component mentioned into it. Now, this slide, which you are seeing here, this has categorized essentially DePIN into two phases. One is a digital resource network, where you just use a digital network, and the second is a physical network itself. And if you see the categories in between them, There are categories which include storage, CDNs, compute, which completely comes under the part of digital part. And then there is a physical network which includes something like Bobcat Miner of Helium, Geo.net, Hive Mapper, and a lot of others where there's a physical component into it. And this has created a basically huge fury, right? Like completely a big kind of debate in the whole industry, where it was started by one tweet which talked about that the rule of thumb is that DePIN projects should have less P rather than having more P. And that's where we realized, and that's why there's a huge debate that, hey, you need to have more P, more physical part rather than more digital part. And the reason behind that, a lot of these cases is that if you have more physical part, it's more difficult to verify. If there's more difficult to verify, there's less scam which happens in the network, and you have a better kind of quality in general. Today, I'm here to talk about that in building DePIN, it might sound counterintuitive, but the lesser P you have, the better it is, both in terms of scaling the network, in terms of unit economics, and in terms of the whole scalability in general. This is basically a debate which has been prolonged for a while now, and now it has been participated and been called as DePIN as well as ViVINs, which is virtual infrastructure networks as well. I want to talk about what we are doing at Huddle01 to solve this. We call this digital verification via QoS, which is quality of service. If you see here how we have divided, the way we are doing audio and video calls right now in itself, or any kind of communication which happens, we have divided this where we don't actively verify all these nodes. Basically right now how Huddle01 solves this problem is that if we five are doing a call, and if you have a good internet connection, you can become a node and you can power the call of all of us, rather than relying on a data center which is very, very far away from you. Now the question here comes that how do you verify such a exhaustive task? And that's where what we do is that we say that we don't generally verify it in a very physical manner. How we verify is that we do a rapid QoS test all the time. And that's where we have divided this subsection into multiple parts. We call it registry, we call it prover, we call it challenger. Where essentially the prover and essentially which is the challenger, what they do is that these are the media nodes which essentially talk to each other, and the prover tries to prove that the task which has done is correct, while the challenger tries to essentially challenge the bit rates and all the other things. So that's where the three kind of components which comes here, which is the bit rate. That means the kind of how much audio video packets are you sending on a per second basis. That's first. Second is how much fraction loss, how much of the seconds or how much of the packets have been lost while doing a call. You would have noticed that when you're doing a call, and if you're sitting in, let's suppose, in any part of the country where the internet is not great, you will see that the quality of call degrades a lot and keeps degrading. So it's basically a function of in the network who has the lowest kind of bandwidth, and that leads to the whole call having not a great quality in itself. So that's where fraction loss comes into picture. And third is the latency. Latency means the round trip time. How much time does it take for you, for the audio packet to receive from my end to your end? And this should be less than 100 milliseconds. There's an internal joke which we always have at Huddle01 that in blockchain, sharding is one of the biggest problems. But what we are doing by doing cascading, that's even a bigger problem to solve, which essentially means that making sure that you're able to create this scalable infrastructure which has a lower latency than 100 milliseconds, and that to cross-continentally, so that you can have a good quality call. And that's what we have been trying to solve for 4 years now. And fortunately, we are here, where we are now able to do the calls in less than 30 milliseconds, where rather than relying on a central server, now you have these digital resource networks based on your own laptop. I can talk about the specs moving forward, but you just require a 4-core CPU, a 4-core vCPU, and you require just essentially a 250 Mbps of internet connection, and you're good to go. I'll go more into detail of QoS tests here. There are a couple of things basically which we have, the couple of simulations which we have run, couple of essentially machinations which we have run to make sure we have come to a essential score which talks about that how do you check that these QoS tests which we do is not easily replicable. That's the problem which every physical infrastructure network is trying to solve in a much more better way as compared to a digital resource network. But that's where we say that digital resource network, if the QoS test is done in a very methodical fashion, includes randomness as a function, includes things like role rotation as a function, includes all these things which make sure that there is no bias in the system, you're able to basically provide the same and even more safer kind of verification out there, which can make sure that there's no essentially game into your system in itself. These are how we calculate the overall scores. And these scores essentially lead us to, if your score is more than 0.8, that means the whole network is performing great. If your score is less than 0.6, then you basically 0.8 and 0.6, then it means that the network has some kind of game in the system. By game, what we mean is very simply doing an audio and video call, and essentially the video is you're receiving the video late. And there's something which is happening with ChatGPT as well right now. ChatGPT basically partnered with a couple of players in the space, and what they noticed was that when I am chatting with my LLM, and while chatting with LLM, the latency was super high. Like essentially, it took me more than 5 seconds to receive a reply of LLM, and that's not is the best way to communicate. You require to have a super low latency. So as we're moving away from this 2D screen environments of communication and moving to all of these new ways in which we're interacting with machines, with drones, with IoTs, and with all these different kind of devices, which means also with healthcare and edtech, where you require a HIPAA compliance so that there's a patient-doctor confidentiality, you require to have these kind of digital verification tests, which is much more important. And the best thing here is that this network can scale way more faster as compared to a physical network, because the logistics is a burden, and you don't actually require that. Your unused compute, your unused storage, your unused bandwidth, we go after the bandwidth industry, is good enough to solve the problem of communication in itself. Now I'll just talk about the couple of subsystems which we have built at Huddle01. These all subsystems are live. For us, DePIN network essentially means that you need to build the demand side first rather than building the supply side. So right now, if you want to use Huddle01, we have basically built a kind of 5-step subsystems. The first is the client side. The client side is our own app. So you can use Huddle01 Meet app, very similar to Google Meet and Zoom, completely built using a mesh network, where essentially you can have a better kind of audio and video calls in general. It's much more safer, it's peer-to-peer in nature, and you can store all these recordings over Filecoin and IPFS as well, making sure that your call quality is good, and also it's much more cheaper in terms of unit economics if you want to store a huge amount of recordings over any of your platforms. And that's why we built the product layer first. Building this product layer made sure that we got social network effects. We have now done more than 6-7 million minutes of meeting on the platform in itself. And then we just compress this, basically use this whole network of ours or the app of ours and convert it into an SDK. So anyone who requires audio video in their own apps in less than 5 lines of code and 5 minutes, they can just integrate this app and they're good to go. Couple of apps on Lens protocol, couple of apps on CyberConnect, couple of games, couple of apps on Farcaster ecosystem have started integrating Huddle01's SDK into their own apps, because anyone who needs synchronous network effects or synchronous communication needs to have audio and video, and dealing with audio and video via just directly a bare web RTC is pretty difficult in that sense. Now, that's where our SDKs comes into picture. Third part is our media nodes, which we all talked about. That's the third subsystem here. So the app side is the first. The second, the middleware, is the SDKs. And the third is the media nodes, which is essentially how we power this bandwidth in itself. Right now, each one of us who are here, we essentially at our own homes have a 100 to 150 Mbps of internet connection, which is good enough to power a normal call. And that's what basically we wanted to show, that if you want to basically solve these hard problems, we have, and the way communication is improving in the sense of the internet speed, both from Starlink, 5G moving to 6G, you have enough firepower at your own unused bandwidths, which could be used to essentially make the communication much more immersive, much faster, and having way better privacy as compared to any of the other centralized solutions out there in the market. And that's where basically this whole subsystem works, right? You can right now out of the box use Huddle01's app on a Play Store, on an App Store, and can do a proper audio and video calls in itself. Talking about the network side of things, which is our media nodes, it's pretty easy to set it up. You just need to have these kind of bandwidth requirements as a minimum. And then there is a bootstrapping reward to make sure that this system scales completely in a good manner. This is where the good part, and that's where what we believe that every DePIN should do, is that build your own demand first. That's one of the most important parts. For building your own demand, you need to have a good amount of product chops, and you need to have a good amount of app which you need to build yourself, rather than relying on others to build the app on you. Because that requires a huge amount of escape velocity, huge amount of product chops, and huge amount of investments to make sure somebody builds on top of you. The better thing to do is build the app yourself on your own network and make sure you're able to basically use that to drive network effects, to make others build on top of you, and also build a much, much more sustainable economy. Talking about here, on our SDKs, since we already power a couple of apps now, a couple of games now, a couple of healthcare now, a couple of edtech now, and a couple of others, we are able to essentially do a total minutes of 1.2 million, and also having a good revenue model here of $4 for every 1,000 minutes. So anyone who needs to use our audio and video component, they can just pay $4 and they're good enough to use our SDKs. On the client side, we have our own app, as I was mentioning, done more than 4 million minutes of meeting, more than 100,000 minutes of meeting have been done, 100,000 meetings have been done. And it's pretty easy to spin it up. You can just spin it up, run it, and use it on your Google Calendar, on your Calendly, or on cal.com. Very easy to use, very smooth. And you will feel the difference when doing the audio video calls. You get a 1080 quality of audio video, and you get a better codec. And these things essentially becomes much more scale out when you start basically doing communication away from the 2D screen to this more immersive kind of communication, which includes multi-haptic communication, making sure that if you are doing a call in a VR and making sure you're playing a game you're playing a Subway Surfer game with one of your friends. Now, the more basically, the more kind of movement you're doing, the more there's multi-haptic motions, the more lesser latency you require. So as we start moving from these communication realms of 2D worlds to these essentially more immersive worlds, we'll start seeing that the latency is such a big problem and how we require this people-powered network to solve this, because otherwise the distance traveled would be so high. So this essentially leads us to making sure that we are much more near to the brink of laws of physics, so that the communication can increase better. We have a better communication, we have a better collaboration, and we can have a better innovation in general. Now, this is what Huddle's economy is. Users join the meeting, apps is used, they pay for RTC services. As they pay for RTC services, they pay that in the terms of fees, and then it's all being done by the media nodes, where the media nodes could be run by anyone having a decent amount of internet connection and a good amount of core CPUs. Now, this is the ecosystem of Huddle01. Interestingly, the apps here, they all use us, either on the SDKs or on the platform side. So if you see in the SocialFi side, these are the apps who already use Huddle01. From the SDK front, in terms of communities, the one who use our platform, the reasons are myriad. The biggest reason for that is, on the app side, is because people are able to do video conferencing and live streaming at once. This is not possible on any platform right now. And then we are able to do that at a much cheaper cost. Think of it like Zoom plus StreamYard merged into one, and you're able to do audio video call, video conferencing, and live streaming onto Twitch, onto X, onto Kick, and onto any kind of platforms as easy as possible. And this is why creators really like using this. Now, this is essentially where we talk about what's next coming up. So we have a couple of things coming up. In October, we are essentially onboarding a couple of our partners. We are also doing our media nodes, which the whitelist of media nodes is open. That means anyone can now run these media nodes themselves. We're doing our white paper unveil. We have been working on the white paper for a couple of years, I'll say now. And then our staking subsystems are coming up. And then Q1, we're doing our TG as well. This is the kind of our whole journey so far. So almost 4 years, and that have infrastructure in more than 10 plus countries, have done more than 7 million minutes of meeting, and now essentially growing fast. This is our team. Our team is essentially of 30 people based in US, India, Europe, and a couple of APAC regions. We come from an RTC background. We have done RTC for a long time now, and being a huge proponent on how the most important thing to solve in bandwidth is RTC. And that's where, if I just basically go back and talk about the RTC component of it, you'll notice that in this bandwidth network map, which you're seeing here, there's VPN, there is CDN, there's AI data layer, there's web proxy, RTC, and transcoding. Most interestingly, if you're able to solve for RTC, which means that able to have a way lower cross-continental 100 milliseconds of latency, that's the hardest thing to solve in a bandwidth category. And if you're able to solve that in a digitally proven way, you're able to make sure that you can have a way, you can solve any of the other things in the category. So if you're able to solve RTC, your network can solve for CDN, a data layer, and all the other things as well. And that's where I'll just culminate my talk, where any kind of DePIN network which is getting built, to scale that network out, there are two things which is very important. The first thing is that you need to build the demand side yourself to make sure that you're able to build a sustainable economy. And second is that if you're able to digitally prove that and make sure that the QoS test is done in a very low latency manner, you're able to have as hard to game the system as hard it is to game the system in a systems like a physical device like HiveMapper and a couple of other devices which is out there. And yeah, that's where I'll end my talk. Thank you so much. And yeah, that's about it.